Hello, good evening. This is Nas from NV Network Lessons. Hope you guys are doing okay. Today's the topic of discussion is going to be deep dive into transistor. Now this might take 3 or 4 lectures to complete my objective. In other words, it might take 4 lectures for me to transfer my knowledge and make you guys well versed to know what a transistor is. Transistor is an important critical component used in electric circuits, and if you are pursuing that field, hopefully this lecture will help you out. So transistor is basically a bipolar junction transistor, and it comes in 2 types, NPN and PNP. As you know that transistors and diodes are made of silicon, okay? So we use silicon to make transistors as well as diodes. So if you look at right here, we call this bipolar junction transistor. Why? Because you have 2 junctions right here, okay? And this is NPN. N is basically material used from semiconductors, okay? N-type material. We extract that from the silicon. And then this is P-type. And then this is again N-type. And then this right here is emitter. This right here is base. This right here is collector. Okay. Now let's look at diode, just for a minute. So if you look at the diode, this is a symbol of diode right here. Okay. And you have current flowing from right to left. You have plus and you have minus, okay? When the voltage is around 0.6 to 0.7 volts in a semiconductor diode, you will have current flowing in the forward direction. So I of F will be present, and what that means is that your diode is active. Okay. Now, if there is no voltage, okay, then your I of R will be 0. So, for example, I go and change the polarity of the diode. So right now I've got positive of the battery connected here, negative of the battery connected here. If I go and change this, make this minus and make this plus, right? Then obviously there's going to be some reverse current, right? Now this reverse current, as long as you have 0.6 to 0.7 volt, that reverse current is going to be 0. But if you exceed that, then you're going to have some I of R. Current flowing, instead of going in this direction, it will be flowing in this direction. So this would be I of forward, this would be I of R. These are the things which you need to understand conceptually, because you're going to be using them in solving the problems later on. Okay. And then also just want to touch base with you. Diode is like this. You have P, N. So this is a silicon, P-type material, N-type material. Okay. And this side is basically anode, connected to anode, which is positive, and this side is cathode. Okay, so these are the things which you must remember moving forward. So let me get back to the NPN. So I will go ahead and erase this, and let's look at the characteristic of the transistor. Let's draw a transistor, NPN. You have it like this. You draw a line in the middle. This is your base. Okay. Then you have a collector going this way. And then emitter is always, if the arrow is pointing outward like this, that's always going to be NPN. That's a way to remember. If the arrow is going out of the transistor, NPN. Okay. So that's your emitter. All right. Now this right here is basically connected to a resistor, and then I have a voltage source right here. Okay. Now let's look at the direction of the current. So in this case, we set a small current which will flow this way. So that's I sub B. Okay. I sub C will flow this way, and I sub E will flow this way. Okay. This is in your NPN transistor. Okay. That's how the current flow. And basically it's nothing but two diodes connected like this. Base. This is basically the configuration. This is actually a transistor. That's how you make transistor. Connect two diodes this way. So in this way, you know, obviously you have plus, minus, and you have plus, minus. So that's the configuration of a transistor. We use just two diodes and connect them like that. And in between is this one right here is the base. Now let's look at PNP. Let's look at the configuration of PNP. So we draw a circle. All right. Draw a line in the middle. This is going to be your base. Okay. And now, in this particular case, keep in mind, this is emitter. However, the direction of arrow in this case is inbound. So right there should be an identifier saying that this is a PNP transistor. NPN outward emitter, PNP inward. Okay. So now what we do is that we say, okay, this is going to be my collector. Okay. All right. So now in this case, you have a voltage source, positive voltage source right here. Okay. And then right here you have I sub C, you have I sub E. Any guesses on which direction would I sub B would be? I sub B would be going out. I sub B would be going out due to the diode configuration, which in this case is going to be like this. So that is the configuration for that is the configuration for the PNP transistor right here, and this is for NPN. Okay. Now one more thing. Your positive source in PNP is connected to emitter. Your base connects to a resistor because we want to control how much current can go in, into the transistor, and it should be really small. And then we connect it to collector, and this is all grounded. Okay, this is all grounded, and in this case emitter is grounded, so keep that in mind. In this case emitter is grounded, in this case collector is grounded. You have positive voltage connected to emitter, positive voltage connected to collector. Okay, so that's what the basically configuration of the NPN transistor and PNP. Now one thing quickly I'm going to mention, there is something called beta, okay, which is HFE value. What is HFE value? It's the current gain. When you go out in the market and buy a transistor, if you are looking for a high gain, okay, you're going to look for a HFE value and buy that according to your circuit. But basically it's nothing but ratio of IC over IB. All right, that's what it is. And then also for both equations, this is true. We can write something like this. We can say I sub E is equal to I sub B plus I sub C, right? We can write that also. And then from here, we can write down I sub E is equal to I sub B. If you recall, it's I sub, actually this is, this is I sub beta into IB. I sub C is nothing but beta into IB, so I can write this beta into IB. And this right here is going to be IB plus. You see how I got this beta into IB? Because if you look this right here, I can bring IB over here, okay? And if I bring IB over here, then IC becomes beta into IB, correct? If you open this up, do some algebra. So anyways, you get this, and you can take IB common, and then inside you're left with 1 plus beta. So these are the formulas you need to remember in order to solve further problems. Thank you so much for watching this. I really appreciate it. If you like the contents of this, go ahead and give me a like and share as much as you can. Till next time.